Okay, hey guys. We are going to do this last part of these notes. I do not think I'm going to include this last example on this video. I'm thinking we can probably go over this in class next time. It's a little bit more just like in depth. It's nothing specific to this section, so. Well, I mean it is. Okay, sorry, that was a bad explanation. But anyways, I'm not going to do it on the video. Using chi-square test wisely. An article in the Arizona Daily Star, April 9th, 2009 included the following table. Suppose that you decide to analyze these data using a chi-squared test. However, without any additional information about how the data were collected, it isn't possible to know which chi-squared test is appropriate. Okay, so we have different age groups and whether they use online social networks or they don't. Explain why it's okay to use age as a categorical variable rather than a quantitative variable. Well, we've grouped like age ranges, right? So everybody who was in the study, all adults 18 and up, would fall into one of these categories. Going back, like way back to chapter 1, which was actually the second chapter we did after chapter 4, we talked about ways that you can turn a quantitative variable into a categorical variable, or a variable that would normally be a categorical variable into a quantitative variable. And there are various ways we can do that. Usually if you're going the other direction, it's by creating a proportion, but we do that a lot, so you're pretty familiar with that. This way works too, though. You have a quantitative variable and you just kind of create ranges of possible values, and then you have categories. So, explain how you know that a goodness of fit test is not appropriate for analyzing these data. Goodness of fit is only appropriate when you have a one-way table. I'm going to look back in the notes from the beginning. Oh, right. Sorry, I don't have my 11.1 stuff out, but there's only one variable, or not one variable. Yeah, it could be one variable. Anyways, a one-way table, though. I feel like I should write more because there's a big space, but hopefully that makes sense. You can't do a goodness of fit test if you have more than one variable. More than one. Right, because a goodness of fit test is comparing to the overall, like the population distribution. So you can have multiple categories, but you're only measuring one thing, like the distribution of color of M&Ms, right? You're not comparing it to some other thing. Hopefully that makes enough sense. So we don't know whether this is a test, we would use a test of homogeneity or a test of independence. The test is performed in the same way, but your hypotheses and your conclusion would be written differently. And so a way that this could have been, the data could have been collected so that a test for homogeneity would have been appropriate. If you remember in class today, or yesterday, 3 days ago, whenever you're watching this video, whenever our last class was, we talked about how the two types of tests are different, and it all comes down to the way that the data was collected. If there's only one sample taken and two variables, so say I'm explaining the other one. Sorry, this is for independence. So I should say if there are two or more samples taken to compare two or more variables, or sorry, okay, let me back up. To test for homogeneity, we would only be taking, more than one sample. So that means we might have taken a simple random sample of just people who were 18 to 24, just people who were 25 to 34, another sample of just people. So we would have 6 separate random samples, and there's only one variable. It's online social network use, right? Either they use it or they don't. So, sorry, that's what I was trying to say. I'll write it down now. Hopefully it makes sense. Right? Homogeneity means, or homo means the same. So homogeneity, homogeneous, means that they're the same. We're trying to see if the two distributions are, or 6 in this case, distributions are equal to each other or not. If the data was collected for a test of independence to be appropriate, then that's where we would only have one random sample, and then we would break up the people in our sample based on what age group they fell into, and then also compare these two. And we would see, is there an association between the age groups and whether or not they use online social networks. Now, these two types of tests would give us the same information, right? Either we would say, basically the same information, right? But the question that we're asking is slightly different, and the way that we would word our conclusion would be slightly different. Okay. I really hope none of that cut out. It had a low battery message on my phone. But I'm just going to do part D, so we'll be good. So how the data are different okay, sorry, I just said this. So hopefully that made enough sense. We'll try to get through that other example either in class on Tuesday or, I don't know, I'll think about it. I might decide to put another video up later, but this video is pretty short, so if you like short videos, then like and subscribe. Okay, I'm done saying that. That's the last time I'm going to say that.